Right, question 4. This question focuses on the reaction between butene and hydrogen bromide. 4.1 asks you to define the term isomer. Some people get into difficulty starting off this definition. It helps if you use the plural, and so it helps by if one says isomers are compounds, and if you give the plural there, it makes the rest of the definition a lot easier. Compounds with the same molecular formula but a different structural formula. So that's the definition. Isomers are compounds with the same molecular formula but a different structural formula. Question 4.2 asks you to state the type of reaction illustrated above. The reaction is between butene, which is an alkene, and hydrogen bromide. And alkenes classically undergo addition reactions, and so we would classify this as an addition reaction. Because it's reacting with a hydrogen halide, you could also call it hydrohalogenation. So either addition or hydrohalogenation would be the correct answer to 4.2. 4.3 asks you to rewrite the above reaction using full structural formulae. I'm going to do that up here. 1 butene, but meaning 4 carbons. 1 butene means that the double bond is between carbons 1 and 2. Now I'm not drawing in all the hydrogens for ease sake, but remember that when you are writing this in your test or exam, you must put hydrogens in to get your full marks. Then hydrogen bromide, they're asking for full structural formulae, so you must show the bond between the hydrogen and the bromine, and that double bond will break. And remember that this is an example of a Markovnikov problem. So as the double bond breaks between carbon 1 and 2, you have to work out which carbon the hydrogen goes on and which carbon the bromine goes on. Hopefully you remember that the Markovnikov rule says that the hydrogen goes on the carbon that already has the most hydrogens. This one already has 2 hydrogens, and so the hydrogen attaches there and the bromine attaches there, and you would then fill in with hydrogens on all the other carbons. So there need to be hydrogen at the end of each of these lines that I've drawn to get you your full set of marks. Now that's the one isomer that can be formed with the bromine on carbon number 2, so 2-bromobutane. Question 4.4 asks you to draw the structural formula of the other isomer. Now if we just draw the backbone as we drew earlier, I said in question when answering 4.3 that to work out which isomer is formed, you need Markovnikov's rule, and we decided that the hydrogen would go on carbon 1 and the bromine on carbon 2. The other isomer is simply to put the bromine on carbon 1 and the hydrogen on carbon 2. Remember there are hydrogens at each of these other points, and that would simply give us 1-bromobutane, which is the other isomer that's formed. Don't be fooled into thinking that they're asking for any isomer here. You could draw another isomer of 2-bromobutane that involved branching, a methyl group off a propane backbone. But this question here, this other isomer, is referring to the other isomer specifically from this reaction. Question 4.5 then goes on to look at a different reaction, a similar situation. In this case we've got propene reacting with water. Remember propene, prop meaning 3 carbons. Propene, the double bond is between carbon 1 and 2, and then we would fill up with hydrogens. First question asks for the type of reaction. Again, because we've got the double bond reacting with water, it's an addition reaction, and so that would be a perfectly good answer to this question. Because it's an addition reaction involving water, You could also call it a hydration reaction involving water. 4.6, state the name of the alcohol most likely to be formed. That's the alcohol over there. So once again, this double bond here is going to break. So if we're going to draw the product, it will again have the 3 carbons. That double bond there will break, and there will be 2 single bonds formed. And so the decision once again is to decide where does the H go from the water and where does the OH go. Markovnikov says the H goes on the carbon that already has the most hydrogens. This carbon here, carbon number 1, has got 2 hydrogens, so the H goes there and the OH goes there. And that means that the most likely product to be formed is this compound over here, which is propan 2-ol. Prop from the 3 carbons, and the OH group, the ol group, is on carbon number 2. So propan 2-ol is the most likely carbon to be formed.